Hello again. I hope you all managed to get outside to measure your pace. Hope you had good weather for it, better weather than I had. But you now know what your hiking rate is. That's important. If you were Grunt and Kronk, you might recall, they had to hike from one place, A, to B, then to C, where there was a mammoth, and I assume some stakes there, mammoth stakes. You could now calculate your distance and the rate that you cover that. However, we also said that you needed some sort of physical characteristics. We suggested a waterfall, but you need something in there. What we use in modern topographical maps is contours. The relief of the area, that is the mountains, the valleys, and everything else, is illustrated by a series of contours. The contour lines represent a given altitude, let's say. You may recall seeing a rock. As the tide comes in on that rock, you see what you see gets smaller and smaller and smaller as the tide comes in, and eventually the tide floods over the top of the rock and the rock appears to be gone. This tide coming in outlines a series of contours. Consider this experiment. If we take a rock, place it in a tank like this, raise water levels in there. In this case, we're going to raise it 1 centimeter at a time. We'll raise the water level 1 centimeter, and a part of the rock is submerged. If we take that rock out and photograph the rock, we'll see an outline of the watermark. Then if we take that rock, put it back in the tank in the same position, raise the water another centimeter, after that take it out, photograph again, we would find the outline of the water, the tide line, is a little bit different. If we did this, say 9 times, as we had to with this rock, we would end up with 9 photographs, each showing the outline of the watermark, the tide mark. Now, if we photograph each of those outlines, take the photograph, outline it with a pencil, then take the pencil outlines, glue them to some styrofoam, we could cut out each of the contours. Ideally, we'd have styrofoam that was 1 centimeter thick. Unfortunately, I was only able to get 1-inch styrofoam. Couldn't even get metric styrofoam. So 1-inch styrofoam, but I still glued on the images, the outlines, and then I cut out the outlines and I glued all 9 outlines one on top of the other. And as a result, we got a model like this. This is a somewhat distorted model of what the rock looks like, but if we take a photograph and look down, straight down on this model, you'll see a series of lines. Those represent contour lines. Each line 1 centimeter above the next. If we take a look at this from the side, you'll see that the contours sort of look like steps on a ladder. No, actually not. If we take a look at from the side, we'll see that each of these contours looks like stairs. If this was the real case, if we were out hiking on a mountain, we might find that we'd have to walk on a flat plane for a while, then all of a sudden there's going to be a cliff that goes straight up, and then there's another horizontal line. That's not the way it is. We also know that the spacing between these contours, in this case on the rock, was 1 centimeter. If we had chosen to raise the water level 1 millimeter at a time, there'd be 10 more contours, contour lines between the ones that we see, so the grade would be that much smoother. Okay.
When we're looking at a change of levels or a change of contours, there are 3 parameters we have to look at. There is the run, horizontal distance, Then there's the rise, and then there's the slope. That's what we get in the end. We have to calculate that. Now, just because we've got a rise and a run and a slope, the slope will be like this. Just because we've got that doesn't mean to say that the ground is going to be either smooth or up here. For all we know, we could have a big lump like this. We'd have to climb over. The slope is just an average. And as long as this never broke that contour line, we'd be in good shape. If, however, we have a lump that comes up way up here like this, we'd see on our contour map a little circle around here, showing that we broke that contour line right here. Now let's look at some calculations. Slope is a measurement of rise over run. So if we want to determine the slope of a given line, we have to calculate first the rise and then the run. So rise divided by the run is equal to the slope. Now suppose we had a rise of 9 meters and we had a run of 30 meters. If we want to calculate the slope, it's equal to rise over run, which is equal to 9 meters divided by 30 meters. And notice it's important that we have the same units in the numerator and the denominator. Now if we want to calculate that out, let's bring in our handy dandy calculator and we'll take 9 divided by 30. That will give us 0.3. And that is the slope. However, we seldom see out on the highway in the real world slope signs. What we do see is signs like this, which is a gradient. This is on a highway, actually from a highway in New Zealand, and it indicates that we're going up a hill and it's a 30% grade. Gradients are different from slopes. Here's one going down, 10% grade. And here's one I particularly like, steep descent, 12%. What that means is that you're going down 12 meters for every 100 meters you go forward. Okay? Now let's look at that 12% slope, or gradient, sorry. And we'll consider it going up, just for simplicity, it's the same thing. So we've got a 12% gradient. That means we're going to go up 12 units, let's say 12 meters. And for every 12 meters we go up, we go along 100 meters. So gradient, that's not the way you spell gradient, is equal to 12 divided by 100, which is equal to 12%. I don't think we need a calculator to do that. But you'll notice that 12 meters going up, that's the same as the rise. So for this same hill, we have a rise, a rise, which is equal to 12 meters. And this 100 meters going along, that's a run. So the run is equal to 100 meters, same units. So the slope is equal to 12 divided by 100. Just to make sure, let's bring in our handy dandy calculator. 12 divided by 100, it equals 0.12. 0.12. Notice the same numbers as in the gradient. Let's correct that spelling while we can. That's an A in there. So if you want to change slope into a gradient, all you have to do is move the decimal place over 2. Slope and the gradient are both ratios measuring the same sort of thing, except gradient is always measured over 100. Slope can be measured over any run. Good. Okay, what we have here is a contour map. This happens to be of Kennedy Island, which is south of Prince Rupert a little bit. The thing that interests us right now are these lines right here. These are contour lines, and you'll notice that they tend to be, well, they are brown in color, and you've got some dark lines and some light lines. Okay? In order to figure out what these mean, you look to the bottom of the chart where you'll see something like this. What it says, basically, says that the contour intervals are 100 feet. Ouch, we don't use feet. We use meters. We're big boys now. So 100, we can convert them. 100 feet here is the same as 30 meters. So when we come back up to here, there's 100 feet. It's actually 30 meters. So if we were to go up this hill, that will be at 30 meters. That will be at 60. The next one over there will be 90, 120, 150 meters, all the way up the mountain. Now, you might argue, how do you know that? Because you might say the tides could go up or down. We never really know where zero is. So what the government has done is they've installed these datum markers all around, up and down the coast. And these are accurate survey markers which predetermine the depth. So a measurement from this is anchored into bedrock. They have to be anchored into bedrock. This one's actually just below Mariners Park, if you're in Prince Rupert. And it, if I remember correctly, is exactly 20.25, I think, meters above I think it's the high tide line. And all these contours are relative to this thing. When you drive out of Prince Rupert, the highway takes you parallel to Prudhoe Lake right here. And if you look down the lake in this direction, you'll see this mountain. This is Mount Blaine. Sorry, it's a little out of focus here. But you'll notice that there's a fairly steep contour, a steep face here. And it's relatively minor going this direction. I've hiked this mountain, but I wasn't stupid enough to go up this way. I came along that way. So if we look at the contour maps over here, you'll see that the lines on the left over here are tight together, very close together, indicating a steep climb. And then the way I came up actually is down sort of this way. I went around that sort of point that came across over here. Let me show how we calculate that. We're going to be looking at climbing this steep part right here. So what I'll have to do is measure that, and I'll do that with a pair of dividers like this. You can use a ruler if you want, but dividers, I can set them at a certain distance and then keep them in that distance. If you use a ruler, you'd have to memorize it. But now what I'm going to do is I'm going to count the number of contours. We'll go right from that one there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 to that one, 14, let's say 15 contours. Each of those is 30 meters. Then we're going to measure the slack side, the easy side. But we'll leave the distance set exactly the same, and we'll go there. Now if we count the number of contours on the right-hand side, you'll notice we're going up 1, 2, 3, 4, well, just we'll say 5. It's really only 5 because it's this little lump. So that's 5 contours. That's 5 contours of 30 meters each. Now you're going to take the dividers, leave them set the way they were, and come down to the scale that's located on the bottom of the page of the map. And here's the scale right here. Now you don't want to use the miles one that's at the top. You're going to want to use the bottom one, which is meters, or the middle one, which is meters. But you see, it's just too long. So rather than start from 0, go out to this side over here and run along there and see that's 1, 2, 3, 4. So the whole thing is 1.4 kilometers, or 1,400 meters. Okay, we've got to keep it in the same units, meters, in order to proceed. Okay, let's start by looking at the west side of Mount Blaine. Now, first of all, we calculated the rise. And we said that the rise was equal to 15 contours. That's going to be 15 times 30, which is equal to, let's bring in our handy-dandy calculator. 15 times 30 equals 450 . And that's meters. Got to remember that. Our run is equal to, if you remember, we said 1,400 meters, or 1.4 kilometers, or 1,400 meters. We've got to remember to use the same units there and there. So therefore the slope is equal to the rise over the run, which is equal to 450 meters divided by 1,400 meters. Let's bring in the calculator for that. So that's 450 divided by 1,400 equals 0.32. No units, because that's just the slope. Now, that's the slope. The gradient is equal to 0.32. Just move the decimal 2 places over, and it's 32%. Geez, I'm wandering all over the page here. Okay, let's consider the east side now. It's the east side. The rise on the east side, if I remember correctly, was 5 contours. So it's 5 times 30. Calculator. Where's the calculator? Five times 30, 150. 150 meters, that's how much we climbed up the run. Now remember, we left the dividers set at the same number. We left it at 1.4, so it's exactly the same. 1,400 meters. Therefore, the slope is equal to 150 divided by 1,400. And that's going to equal, calculator, clear, 150 divided by 1400 equals, let's say 0.107. 0.107. Therefore, the gradient is equal to, 2 decimal places over, 10.7%. Quite a lot easier than the 32% we got up here.
Now you've learned how to read contours on a map. You've also learned how to calculate slope and gradient. And hopefully you'll know the difference between them. A little subtle, but you know the difference between them. Remember, always cancel out your units. I'd like you now to go to an assignment I have in the assignment page, SENV 102 L3. This assignment asks you to get hold of a topographical map, hopefully one of your own, from your own area. Find a couple of mountains on the map, or hills if you don't have mountains around. Calculate the slope and the gradient for one side of the mountain to compare to the other side of the mountain. So 2 sets of data for each mountain. You can send it off to us then. We hope that you've enjoyed doing this, the slope and gradients and the contours. And we look forward to seeing you in the next lesson. Seeing you is kind of a little bizarre. We look forward to you seeing me at the next lesson on the compass.